Welcome to derivatives of exponentials. So recall that if we wish to take the derivative of e to the x, this is a special function that just spit back out itself, e to the x. And also recall that we have the chain rule. Right? So if we have want to take the derivative of g of f of x, that was equivalent to g prime evaluated at f of x. And then we multiplied by f prime of x, right? So we have our derivative of the exponential and our chain rule. And then the other thing that's going to be of use to us in just a moment is if we raise e to the natural log of b. This is simply b by definition of the natural log. Natural log and e to the x are inverses of each other. And then we're also going to take advantage of the fact that if we raise e to one power followed by another power, that's the same thing as e raised to the m times n. So all of these pieces of information are going to be useful in figuring out the derivative of an exponential that has a base other than e. So as I had putting the two together, we're actually going to put the four facts together. Let's go ahead and find the derivative of f of x equals 3 to the x. So what we need here is we need to rewrite this in the form of e to the something. That's the only exponential so far that we know how to take the derivative of. So we're going to rewrite this as e to the something. Right? So we're going to use that e to the natural log of b equals b. So what we're going to do is we're going to use the fact that 3 is the same thing as e to the natural log of 3. So if we use this fact, then we have f of x is equal to e raised to the natural log of 3, that whole thing raised to the x. Now we're going to manipulate this so that we no longer have the to the x on the outside. So we're going to use our exponent rules. Raising to one exponent followed by raising to another exponent, we get that f of x is equal to e to the, we can go ahead and just multiply those two exponents. We have natural log of 3 times x. At this point, we now have a chain rule. So our inner function will be natural log of 3 times x. So our inner function, I'm going to use u again. U equals the natural log of 3x. Natural log of 3 times x. And then our outer function we are looking at e to the whatever, e to the u, right? So if we go ahead and take the derivative of this, so we're going to now use the chain rule. We have that f prime of x is equal to the derivative with respect to u of e to the u times the derivative of u with respect to x. And we know that the derivative of e to the u is just e to the u. And then we will also take the derivative of u with respect to x. Plugging back in, u was equal to the natural log of 3 times x. So we have e to the natural log of 3 times x. And then we are multiplying this by the derivative of, sorry, not e, the derivative of the natural log of 3 times x. At this point, again, I'm going to just leave this as e to the natural log of 3 times x. And then the derivative of natural log of 3 times x, we wind up just with natural log of 3. And from here now, we're going to just do some manipulation. So we earlier noted that 3 to the x could be written as e to the natural log of 3 times x. We did this earlier, and so we wind up getting then f prime of x is equal to 3 to the x times the natural log of 3, or we would usually write this as natural log of 3 times 3 to the x. So in all of what we did, there was nothing unique to using 3 here. It could just as easily have been any other number. So in general, we wind up getting that the derivative of b to the x is simply equal, oops, the derivative of b to the x is equal to the natural log of b times b to the x. And this is for b greater than 0. B greater than 0 and b not equal to 1. 1 to the x is just 1, right? So it's not a particularly interesting exponential. All right, so using that, we can go ahead then and find the derivative of g of x equals 5 to the x. So just by using that rule, we know that g prime of x should be equal to the natural log of our base, 5, times 5 to the x. So this lets us now very quickly find the derivative of any exponential instead of having to do the algebra manipulation and use the chain rule as we did for the previous example.